In earlier lecture videos, we discussed about normalization and why we go for normalization and different types of the normal forms. In this video, let's see about normalization algorithms. So in the normalization algorithms, first we'll start with inference rules for functional dependency. We already know that what actually functional dependency means. With the help of that functional dependency, we can derive the new functional dependencies. So those functional dependencies, if you want to get derived from the given functional dependency, that we call as an infer. So here, given a set of functional dependencies F, we can infer additional functional dependency that hold whenever the functional dependency in F hold. Okay. From the given functional dependency, we can derive the new functional dependency. Deriving the new functional dependency from the given one, we call as an infer. So for deriving that, we can have the different types of the inference rules. Okay. So those inference rules also call as an Armstrong's axioms, because these are the inference rules developed by the scientist Armstrong here. So actually you are having the 6 inference rules. Among 6, first 3 inference rules are the direct rules, and remaining 3 rules are indirect, which are derived from these basic rules here. So let's see first rule, that is the IR1, inference rule 1. That is reflexive. Reflexive rules, what it tells, if y is subset of x, then we can tell that x determines y here. So y is functionally dependent on x. So here this may be trivial and non-trivial. Here you are using the trivial and non-trivial. Trivial functional dependencies. Here in that we are using the two terms. Trivial means what? If y is the subset of x, that one we call as a trivial here. Non-trivial, it is reverse. If y is not a subset of x, that is what we call as a non-trivial. So non-trivial is what? If y is not a subset. Trivial means what? If y is a subset. If y is a subset, then you can tell that y is functionally dependent on x, and that one we call as a reflexive. Even you can also tell that x determines x only. X determines x itself means what it is. That is also what it is. X is a it is a subset of the x here. That one also you can take here. Next is the IR2, that is the argumentation. Second inference rules is we call as an argumentation. What it is, let's say if x determines y, then if I add any additional attributes on both left hand side and right hand side, it doesn't make any difference to your functional dependency. See here I am adding the one more extra attribute on both the sides. It may be set of attributes or single attributes. Here x and y means what it is? It is maybe set of attributes or maybe single attributes. If I add same attribute on both the side, then it doesn't make any difference to your functional dependency. So that is what we call as an argumentation. So argumentation, what xz stands for here, it is x union z, means what? You are adding one more extra attribute set or attributes here. Z may be attribute set or Z may be attribute, single attribute here. Next is inference rule 3, that is transitive. What it tells, let's see, if x determines y and y determines z, then we can tell that is what? X determines z here. This rule what we call as a transitive rule. See here, given functional dependencies are what here? X determines y and y determines z. So these are F now. So with the help of this F, if I can derive the new functional dependency. So what is that? It is based on the transitive rule. I inferred new functional dependency, that is what? X determines Z, and which rule you are used here to get this new functional dependency or to derive this new functional dependency, that is the transitive rule here. And this IR 1, 2, 3 means inference rules 1, 2, 3, it is we call as a sound and complete set of inference rules. As I told, these are the basic rules of the inference, and these are direct and complete set. Next remaining rules we call as a additional inference rules, which are also useful. So first one is IR4, that is the inference rule 4, decomposition or projective rule. So what actually decomposition and projective rule tells? Let's see. If given functional dependency, that is x determines yz. So x is one subset, okay, set of attributes, and y is one more set of attributes, or z may be one more set of attributes or individual attributes. If this is the functional dependency is given, then I can tell that x determines y and x determines z here. It doesn't make any difference to your functional dependency here. So this one what we call as a decomposition or projective rule here. Next one is union. Inference rule 5, that is we call as union or additive rule. If x determines y and x determines z, okay, then we can write like this: x determines yz. You are adding this to as a, okay, what it is. So we are taking as a, instead of taking two functional dependency, here we are considering only one functional dependency, and here we combining the y and z set attributes here. So this one we call as what now? Union or additive rule. So whereas here if x determines yz is given, then you can that one as, okay, can get as a two functional dependency. Instead of taking this as a single functional dependency, you are decomposing as a two functional dependency, x determines y and x determines z. So whereas union and additive is reverse of the decomposition. So if two functional dependencies are there, that one you can determine like this, okay. Next is IR6, that is inference rule 6. This one we call as a pseudo-transitive rule. So what pseudo-transitive rule tells? Let's see. If x determines y and wy determines z, okay, then we can tell that wx determines z here. So here w is what it is the, okay, here you are taking that as what it is, x determines y and combination of wy, okay, determines z here, then you can write like this: wz x determines z here. It is very simple here, okay. As we know that, okay, y is functionally dependent on x and z is functionally dependent on y and w here. So if I use the transitive rule, z is what it is functionally dependent on x here, and here, okay, y is, okay, you are telling that is what it is. So z is functionally dependent on w and y. By applying transitive rule, I can remove this y and I know that x here, okay. So that's why you are using the term as a pseudo transitive rule here. The last three inference rules as well as any other inference rules can be deduced from IR1, IR2 and IR3. That is what we call as a completeness property. So as I told earlier, so those first three rules are, okay, direct rules, and these three rules are indirect because you are deriving these rules based on the first three rules here. So these are the 6 inference rules which are used to infer the new functional dependency from the given functional dependencies. So next, based on the inference rules, we can get the closure of a set of f of a functional dependency. It is denoted like this: f set. So of all FDs functional dependency that can be inferred from f. So f is the given set. So for that, okay, given set means what? F it is contain the set of functional dependencies. So after using inference rules, you may get the new, okay, new functional dependency which are derived from this given functional dependencies. So all those things if you are combined, that is what we call as a closure set, okay, closure of functional dependency. That one you are denoted like this: f plus is what it is the set of all functional dependencies along with the new functional dependencies derived from the given functional dependencies which are there in the f here. Next, you are using one more term, that is closure of a set of attributes x with respect to f. In the f you are having the set of attributes. So all those new attributes whatever you derived, no, that is what we call as a x plus of all attributes. Closure of x is x plus here, that are functionally determined by x here. X is one, okay, set of attribute. So now this is available in your given functional dependencies F here. After using inference rules, if you are get the new attributes, if you are okay, get the new attributes for the given functional dependencies. So those attributes, if you are combined along with the given attributes, new attributes, if you are combined, no, that is we call as a closure set of attributes. That one you are denoted like this. X plus is what it is? Set of all attributes which are derived from using the given, okay, functional dependency with the help of the inference rules. So x plus, that is the closure of x, can be calculated by repeatedly applying IR1, IR2, IR3 using the functional dependencies in F. In the F, what are the functional dependencies you are having? No. So for those functional dependencies, I can apply these inference rules. After applying the inference rules, if you get the new attributes, if it is added to x, that we call as a closure of x, that is we denoted like this, x plus. So let's see what actually closure set or attribute closure. Definition. For each such set of attributes X, we determine the set X plus of attributes that are functionally determined by X based on F. X plus is called the closure of X under F. F is what now here? F is the functional dependency. Okay, F is the set of functional dependencies and X are the number of attributes available in that particular functional dependency. So for determining this closure of X under F, okay, one algorithm is available. Let's see what that algorithm is. So for the algorithm, input required are a set of, okay, a set F of functional dependency on relation schema R. So for the given relation schema, what are the functional dependencies are available? Those functional dependency set we call as like F here. And set of attributes, all the attributes of the relation schema, which is a subset of R here. Okay, so that one you are considering as a subset of attributes X here. So now x plus, I need to find the closure of x under F here. So for that, what is the procedure here? X is the sum of the attributes which are available in this functional dependency set here. Those attributes now at present I am having only those things. That one I'll take as a closure of x here. Next I repeat the procedure. What is that procedure? I am taking one more variable, that is old x plus. This is the x plus, and later I'll try to get the remaining attributes. That one I'll take as a x plus here. For each functional dependency, y determines that in F. So in F, F is what it is? It is a set of functional dependency. Y determines Z is one functional dependency. Then if x plus, okay, this y is subset of this closure set. Then what is the procedure you have to do now? So you have to add that Z to as a, okay, you combine or you add that to be the this closure set here. So like this you will combine all the attributes what are available in the set F. So based on the criteria, what is that criteria? If y is the subset of this closure, then you will add that as, okay, Z to the x plus here. X plus means what it is? It is closure of x under F. And this procedure you repeat until all the attributes, what are the attributes are available in F are checked. Okay, once if it is verified and all the attributes if it is subset, then you are adding those attributes in the closure. In this way you are finding the closure of X under F here. Okay, so let's see same algorithm with one example. Assume that this is the given relation schema A and A contains the attributes relation schema R, and R contains the attributes A, B, C, D. And this is the functional dependencies, okay, set. Here I am taken as a FD, actually it is F. And here number of functional dependencies are, one is A determines B and B determines CD and D determines C. These are the set of functional dependencies here. Now I need to find the closure of X here. Okay, now here X is what? This is your X and this is your Y here. I want to find the closure of X here. So X is what here? X is A here. So closure means how will you denote that one? A plus here. So now after applying the inference rules, I got closure of A plus is A, B, C. Actual given functional dependency tells us what it is. B is functional dependent on A. After using the inference rules, I'll get to know that even C and A are also functional dependent on A plus. That is the closure of X. So as we know that here I'm using the inference rules, that is the reflexive. So in the reflexive, what it tells, A determines A, it doesn't make any difference. Okay, A is dependent on A only. That's why here I'm taking that A also, okay, functional dependent on A itself here. Next is by applying that, this is your given functional dependency set. So here they given A determines B and B determines C. Okay, so after applying the decomposition rule, I got the relation what it is, B determines C and B determines D here. So by applying the transitive rule, I will get to know that A determines B and B determines C. Then I can tell that is A determines C here. So now after applying the IR3, I will get to know that C is also functionally dependent on A here. So this is how we are getting the two more attributes in this particular closure set here. Okay, A, B, C here. So now this is what we call as A plus here. In the same way, you need to find, this is your given functional dependency and this is your X and these are Y. Okay. So I want to find the closure of B. So that one I'll denote as a B plus, and after applying the inference rules, I'll get to know that CD is already there. CD are functionally dependent on B. Now after using the reflexive rule, I'll get the B also. So closure of B is what it is, BCD. The same way here given functional dependency is what, D determines C here. After using reflexive, I'll get to know that D is also okay. Like this, if you take, it doesn't make any difference to your functional dependency. So this is what we call as a closure set or attribute closures here. Okay, is it clear now? Thank you.